This is the video notes for the 5.2c more or less activity. This activity starts with a jump start and it asks us to graph 3 inequalities. So I'll go ahead and do that. Okay, so this first one we need to subtract 3 from both sides and then divide everything by 2. We get x is less than or equal to 2, so I'll put a 2 here, I'll put a closed circle, and I'll go left. On this second one, we also need to solve for x, so I'm going to minus 3 again from both sides, and then I get 2x is greater than or equal to 4, and I get x is greater than or equal to 2. So same boundary number, but this time we have a closed circle going right. Okay, let's see the next one. This one we're also going to minus 3 from both sides, and we're going to have 2x is less than 4, and we get x is less than 2. So again, our boundary number is 2, but we have an open circle this time, and it's going left. Then it has a follow-up question. Since all of the coefficients are the same, what accounts for the difference in the solution sets? Well, the difference in the solution sets has to do with the inequality symbol. That is what is making the difference in the solution set for each of these. Let's go ahead and turn the page. Go to our launch, which has us do a few problems in order to solve the following systems of inequalities. So let's go ahead and do this first one. I'm going to model this first one by using intercepts. So let's show that. Negative 5x plus 3y less than or equal to 45. So I'll graph this by finding the x-intercept. The x-intercept is where y equals 0. That's going to be 45 divided by negative 5. That's going to be at negative 9, 0. And then the y-intercept, that's where x equals 0. That's going to be 45 divided by 3, which is 0, 15. Okay, so I'll go ahead and graph those. Negative 9, 0 is here, and 0, 15 is up here. This has a less than or equal to, so it's going to be a solid line. And the shading for this is a less than, so it'll be shaded below. I'm not worried at all about the sign flipping for this because there's a positive number in front of the y. It's positive 3y, so I'm not worried at all about a sign flip. So this would be shaded here below. I'm going to go ahead and graph a second inequality using intercepts as well. So let's go ahead and find those intercepts. So for the second inequality, I guess I'll just write it smaller over here. So for this one, the x-intercept is going to be 24 divided by 2, which is 12, 0. And then the y-intercept is going to be 24 divided by 3, which is 0, 8. Okay. This one will have a dotted line and shaded above because of the greater than symbol. Okay, and I'm not worried about a sign flip because in front of the y it's positive 3, so no sign flip there. Okay, so 12, 0 is here, 0, 8 is here. This is a dotted line. And shaded above. So you can see where the double shading is. This is upper right corner. So that's where I'm going to shade in really dark. Or a different color. There you go. So all the solutions to this system of inequalities would be located in this zone over here. So I could choose any of these ordered pairs, and those would be solutions to this system, because that's where it's double shaded. Okay, let's go ahead and graph number 2. Number 2, there's a typo on the 30. Instead of 30 right here, it should be 36. And you'll see why in a minute. I'm going to graph this one by solving it for each inequality for y, and just show that way of graphing it. So I have negative 10x plus 6y less than or equal to 90. I'm going to add 10x to both sides. And I bring down my leftovers. And then divide everything by 6. And I can simplify as I go here. So y is less than or equal to 5 over 3x plus 15. If I graph that, I'm going to put a dot at 15 on the y-axis, and then I'll go up 5, right 3. Each box is worth 2, so that will be right here for up 5, right 3. Or I can reverse it and go down 5, left 3. This one will be a solid line and will be shaded below. I'm not worried about a sign flip on this one because in front of the y was a positive 6, so there will definitely not be a sign flip. Definitely was not a sign flip as I was solving for y. Okay, let's go ahead and solve the bottom one for y. So I'm going to do that right here. 6, let's change my pencil. 6x plus 9y is 36, minus the x from both sides. I get 9y equals negative 6x plus 36, and then we divide everything by 9. So we get y equals negative 2/3 x plus 4. And then that is graphed like this. Point at on the y-axis at 4, and then we go down 2, right 3, down 2, right 3. This one will be a dotted line and shaded above. So there's no sign flip, so I don't have to worry about that. And Then once I have my shading in for this one, I see where the solution is for both of them. It's this upper right corner right here, this one. That's where my solutions to the system are. So if I chose any point over here in this double shaded zone, then that would be a solution to the whole system. Okay, so this is the sweet spot up here. Okay. Number 3 asks a question, is the point -310 a solution to the system in problem number 1? So we're going to graph it and see if it's in the double shaded region. So -3, 10 is located right here where the two inequality boundary lines cross. And I'm going to say no, this is not a solution to the system, because even though one of the lines is solid, the other one is dotted, and it has to satisfy both inequalities because in order to be a solution to the system. Okay, so I'm going to say for number 3, nope, no, it's on a dotted line. Doesn't satisfy both inequalities. Okay. Now we move on to number 4. In number 4, it has us write the system of inequalities whose solution set is shown. So we've got this graph where we've got 3 inequalities graphed. So we're going to go ahead and write the inequalities that represent that graph. And I'm going to say this is inequality A. And then I'll do this one over here is B. And this bottom one here is C. That way you know which one I am talking about. Let's move the label for A over here, line A. Okay. It's easiest to write these as slope-intercept form. So let's do that. So A is going to be Y, and it's shaded below, and it's a solid line. So less than or equal to, looks like it crosses at plus 10. I have X, and then it looks like the slope is up 3, right 2. And you could tell because here's a really good point, here's a really good point, and we go up 3, right 2. So that'll be the slope for this one. For our next one, the Y is, this one is shaded also below, so at a solid line less than or equal to. Looks like the slope for this one is down 5, right 2, so -5 over 2 with the X, and it also crosses at plus 10. For my third one, C, looks like it's shaded above and also solid, so greater than or equal to this time. And I think that the slope is up 1, right 6. So 1/6 X, and then it crosses over here at plus 2. Okay, so when you write the inequalities that represent a system of inequalities, again, it's just easier to write them in slope-intercept form. Number 4 has us pretend that a guy named Frank completed number 4 and wrote those inequalities. And it says, Amanda is examining Frank's work on page 4 when she exclaims, "You've written all of your inequalities backwards. The solution set to your system would look like this. What do you think about Amanda's statement?" Well, I disagree with Amanda. I think that Frank is correct with the inequalities that we have up here. Like, I think those look good. So I think that she's confused about the direction of the signs. So, so I think that her graph here is basically all the signs flipped. So I'm going to say she flipped all her signs. And what's interesting about when she flipped all her signs is that she doesn't have a solution anymore. There's no zone that's triple shaded. There's double shaded areas, but nothing triple shaded. So hers would be no solution. Her graph would be no solution. Okay, let's go ahead and move on to number 6. In number 6, if we go back to Carlos and Clarita, and then it says that they found a cat food that seems to appeal to even the most finicky cats, Figaro Flakes. They want to mix it with a less expensive cat food, Tabitha Tidbits, to make an affordable but tasty cat food. Tabitha Tidbits contains 4 grams of protein and 6 grams of fat per scoop. Figaro Flakes contains 12 grams of protein and no more than 6 grams of fat per scoop. So we need to write and solve a system of inequalities that Carlos can use to determine possible combinations of each of the cat foods so that the constraints are satisfied. The first thing we always do when we're setting up a system is we need to define our variables. So why don't we make x be scoops of Tabitha Tidbits? Okay, because remember that we're doing a combination of each cat food. So x will be the first cat food, and let's say y is Figaro Flakes. So we have that done. Now the next thing is to write our 2 inequalities. One's going to be about protein. So anything about protein will be in this inequality, and the other one will be about fat. Okay, so let's do the one about protein first. So anything that has to do with protein, I'm going to highlight. So it has to have at least 8 grams of protein, so that's important. And then Tabitha Tidbits has 4 grams of protein, and Figaro Flakes has 12 grams of protein. Okay, so let's go ahead and put those things in. So Tabitha Tidbits is x, so we're going to go 4x. Figaro Flakes is y, so we go plus 12y, and that has to be at least 8 grams of protein. So really they want more, so greater than or equal to 8. Now I'm going to go ahead and highlight anything that has to do with fat. So no more than 6 grams of fat. Tabitha Tidbits has 6 grams of fat, and Figaro Flakes has 4. Okay, so let's fill that one in. Tabitha Tidbits is 4, so we go 4x plus, and then, oh, sorry, Tabitha Tidbits for fat was 6 grams of fat, so we go 6x plus, and then 4 grams of fat for Figaro Flakes plus 4y, and that's no more than 6, so less than or equal to 6. All right, now that we have those set, I'm just going to use intercepts in order to graph this. The x-intercept is going to be 8 divided by 4, so that's going to be 2, 0. And the y-intercept is going to be 8 divided by 12. So I think that's like 0.66, so 0, 0.6. Let's graph my first one. So I go there, and right about there, and then I put solid line, and this one will get shaded above. I'm actually gonna wait to shade until I have the other one on, and then I'll see where the double shading is. So for the next one, the x-intercept would be 6 divided by 6, so it's 1 comma 0. And then the y-intercept would be 6 divided by 4, which I think is 1.5, so 0 comma 1.5. Okay, I'm going to change my color for this one to put on the graph. So it's like here and here. So we put that there. Now remember, the protein constraint is the red one, and so that was shaded above. So my two options for above are here or here. And then my fat constraint was shaded below, and that's the blue one. So here or here. So you can see it's double shaded in this zone, and so that's where I have my solutions. So let's go ahead and answer number 7. It says, based on your work, what are some possible recipes that satisfy the situation? So I'm going to say like this ordered pair here is good. So I think that's 0.25 scoops of Tabitha tidbits and 0.75 of Figaro flakes. Or I could do this one here, 0.25 and 1. Or how about this one right here, 0 and 1? That also works. Okay. Let's go ahead and do our takeaways, and then we'll be the end of this activity. So the takeaways ask, describe a procedure for modeling a context using a system of inequalities as constraints. So always the first thing that you need to do is you need to define your variables. Okay, so define variables. Once you've defined your variables, then it's really important to write your inequalities. Then when you have your inequalities, go ahead and graph the boundary lines. Okay, and then shade the correct double shaded area. So shade the correct region. Okay, and then once you've shaded the correct regions, you need to decide where it's double shaded. Decide where it's double shaded. That is where you have solutions to both the inequalities. Okay, that region, this region of double shading represents all the combinations of solutions. Represents all the combinations of solutions that satisfy both constraints. Right. So I think that's a good process or procedure to model a context using a system of inequalities. Define your variable, write the inequalities, graph the boundary lines, shade the correct regions, decide where it's double shading, and then choose combinations from that double shaded region because that's where both constraints are satisfied. I hope this video was helpful. In the end, we learned how to differentiate between linear inequalities in two variables written as strict inequalities, paying attention to signs. We also practiced finding the solution set for systems of inequalities. Thank you so much. I hope this was helpful. Good luck on your practice.